Thank you. So, what happens here is that yesterday we talked about the different types, different classifying stuff of angles themselves. Today we start talking about the relationships that occur within them. Now, when we say angle pair, that means how many angles do you think we're talking about? Two. So the first two that I always like to talk about with you guys with this stuff are the ones that I know that all of you guys have seen. For example, you guys have seen what are called complementary and supplementary. You guys have all dealt with those terms before. It's one of the first geometry terms that most classes go over as far as vocab. Now, when we're dealing with what are called angle pairs, we're talking about two. Okay? We're talking about the relationship between two of these. So when you have complementary angles, it's two angles whose sum is 90. If you're not going to write this down, don't talk to other people, please. And don't blow your buzz while we're in class. Thank you. Okay? And then the other one, then, if one of them is goes to 90, what do you think the other one's going to go to? Now, this may sound like the silliest way to remember this, but what comes first in the alphabet, complementary or supplementary? What comes first as you're counting, 90 or 180? Yeah, and that's the idea. Now, with complementary and supplementary, there comes along another term. Did you guys all see on the back wall there, I wrote angle 2 and I made a little angle and I put 60 degrees in it? Well, if I put an angle here, call it angle 1, and I call this 30 degrees, those are two angles, right? Do they add up to equal 90? Are they complementary? Yeah. Yes, but are they next to each other? No. Okay. Now, same idea. There's a 120 degree angle over there in blue, and there's that 60 degree angle in the back. Are those two angles supplementary? Yeah. They still add to 180, right? But are they next to each other? No. So there's another term that comes into play with some of this stuff, and it's called adjacent. Adjacent angles. Those are angles that are next to each other. Because they share a side. Okay. For example, in here, I can just say that angle 1 and angle 2 are adjacent. They're next to each other, and they share a side. Oops, I'm sorry. Anyway, not only do they share a side, they share a common vertex. Okay? They share a side and a vertex. Non-adjacent would be angles that aren't next to each other. Exactly. So, in essence, you could have complementary angles that are either adjacent, or you can have complementary angles that are not adjacent. Same thing with supplementary. It doesn't matter. Okay? They can either be, example would look like this. Those two angles would be adjacent, a 20 degree and a 70 degree. They're right next to each other, and then a lot of times, remember how I said you'll see that little box? That little box denotes that it is a right angle. Two angles that are next to each other, then there you add up to equal 90, they're complementary. That's what that means. Okay? That would be adjacent. These are adjacent complementary. I use abbreviations. ADJ comp for adjacent complementary. Is that all right? I hope. And then obviously if I wanted to do the non-adjacent, like we did a second ago, I could put 30 degrees, 60 degrees. Those would be non-adjacent complementary. They still add to this. They still add to 90. They don't necessarily have to be next to each other. Not terrible. And like I said, it works the exact same way for supplementary. Okay? It does the same exact thing for supplementary. When you have those would be adjacent supplementary angles. They're next to each other. They share a vertex, share a side. And then, like we did a second ago, we had the one where it was 120, 60. Those are adjacent. These are non. Usually that's not very difficult to see the differences. See if they're next to each other or not. So let's see, we got lists. Complementary. Maybe the 90. Supplementary. 80. The adjacent supplementary, what do those two angles create? We have adjacent supplementary. What does that picture make? We look at those two angles. That 110 and the 70. What does that create? The adjacent supplementary, the 110 and the 70. What does that make? It's a straight angle. What do we call a straight angle then? One. These, when they are adjacent supplementary, you know it's a lot of words here, you get what's called a linear pair. Okay. Linear pair is just a more specific supplementary angle. And it comes from the root line pair. Two angles that make a line. Really, really easy. Two angles that create, I should say two adjacent, that create a line. Their sum is 180. Yeah, that really isn't anything that you couldn't have figured out. And I think we've probably even done a problem or two that kind of looked like that, and you were already figuring out, so it shouldn't be so bad. Excuse me. All right. So, complementary, 90, supplementary, 180, linear pair, 180. Okay. Now, the other one that gets in here is when you draw something a little bit different. What I'd like you to do is take and draw two lines that intersect at just one spot. What do you mean? Yeah. Because it marks the spot, doesn't it? It'd be okay that two lines intersect. If they intersect at one spot, they intersect at one point. When you have two lines that intersect at one spot, how many angles are created? 4. Good. Is it okay if I label them 1, 2, 3, 4, just going around clockwise? The order in which I label them doesn't matter. It's just how I decided to label them. It does matter how. Anyway, what can you tell me about angles 1 and 2? Adjacent supplementary, not necessarily the same. They're adjacent supplementary. What's the fancier name for adjacent supplementary? Linear pair, very good. Now, if you just remember, oh, they're adjacent supplementary, which meant they have to add an equal how much? 180. If you knew that much, you would have been fine. Okay, you would have been fine. Knowing that it's the next level of, oh, that's a more specific term, linear pair, that would have been even a little bit better. But in order to do the math, you would have been fine with that. Yes, sir. Which ones? What do you mean by all of them? Which ones are linear pairs? List them. 1 and 2. 3 and 4 are, okay. 4 and 1. 2 and 3, very good. Now, what you're getting at here is, or what I want to show here is this. You guys agree that angles 1 and angle 2 are a linear pair, adjacent supplementary. So are 3 and 4. But I'm going to do something with 1 and 2 first. What do angles 1 and angle 2 have to add up to equal? 180. So I know that angle 1 plus angle 2 is 180. What else adds up to equal 180? 4 and 3. What else? 2 and 3. Okay. I'm going to switch to 2 and 3. We know that angles 2 and angle 3 also add up to equal 180. Angle 2 plus angle 3 equals 180. Are you okay with that? Okay. Now, put your pens down for a second. What's x? 3. Good. So if x is 3, what do I do with that x value to figure out if I'm right or wrong? I substitute back into here, because anywhere I see an x, I can replace it with a 3. Because when things are equal, they're replaceable. Did that ring a bell? Now, oh, that was funny. That was good. I didn't plan that. I'm not that good. What two things equal 180 here? 1 and 2 and 2 and 3. You're not wrong. But according to what I have written down right now, does everybody see how 1 and 2 is 180, 2 and 3 equals 180? Don't both of those equal the same thing? That means don't those two things have to equal each other then? Think of it in terms of variables. What's the same on both sides of the equation? Angle 2. So if I wanted to move an angle 2, what would I do? Subtract it. Very good. So I subtract an angle 2. And I apologize when we're doing algebra with a lot of the symbols here. You're left with angle 1 equaling angle 3. Well, watch what happens. If I say that angle 1, for example, is 110 degrees, by definition, what does angle 2 have to equal? 70. By definition, then, what does angle 3 have to equal? 110. By definition, what does angle 4 have to equal? 70. Does each set of consecutive angles add up to equal 180? Yeah. Because they're all linear pair. Now, notice we backed out angle 2 on both of those because if you look at it, they're overlapping the same thing. That means that's That's right. And it also means there's another thing that happens here. Whenever you get two lines that intersect at one point, you get four angles that are created. More often than not, I mean, you could have just one special angle, one 90-degree angle all the way around. But the angles that are opposite one another will always be equal. That has another term for it. Okay? When you've got two lines that intersect, angles that are opposite one another, they share the vertex and their sides create the lines. Those are called vertical angles. Those are angles that are created by two lines and their sides that's a bad definition. Try this. Sorry. Angles share a vertex, and sides make lines. I'll highlight this and you'll see. What I mean with the vertex is where the point where they intersect is always the same. And then if you look at the sides that create those angles, you've got the, for this example, you see how I've got that V going up and that V going down? Well, the V that's going up and to the right connects to the V that's going down and to the left. Same thing going the other way. The V that's going up and left connects to the V that's going down and right. That's where it comes into the idea that their sides create the lines. Okay. So when you have two lines that intersect, you get two sets of what are called vertical angles. Angles that are across one another on either side will always be equal. When we get into a lot of stuff later on, this statement becomes very, very important. Okay? One of the things that we do in geometry, about a month or so out from it, is that we start to deal with what are called triangle proofs. And when we get those, we wind up using a lot of definitions. For example, I'm not writing any weird stuff out. If this spot is the midpoint of this section, the whole thing, what do you know about the two smaller parts? They're what? They're the same. That means they have to be equal. Okay? Same thing, if this point is the midpoint on the other side, these two have to also be the same of each other. Is this two lines intersecting? Yeah. This angle here and this angle here has to be the same because they're what you call vertical. This is the kind of stuff that we use, first couple weeks of school, we're talking about definitions that'll lead us later on to be able to do this stuff. This isn't now, this is nothing to worry about for right now, but what I'm saying is that you're going, all these little definitions and things that we use them again in a couple of ways. All right? Complementary, supplementary, linear pair, adjacent, not adjacent. The vocab of geometry is what's usually new to us. The algebra that we use, as you guys can see, is pretty easy. All right? But it's the vocab that allows us to do things. All right? So far, so good? Let's look at algebra with this vocab then. And what I've been doing here is kind of jumping right into the more, I don't want to say tricky, but a little bit more of the weirder looking stuff. So why don't you guys take a minute on this one. Solve for x and y, please. Take a second and solve for x and y, please. On this. You guys all see that one all right?
Yeah.
Take a second, solve for x and y, please. Y and me, please. So everybody gets a chance.
All right. I'm not here.
Don't check that.
Oh, yes.
And you want
The one that whatever that
Holding this going, hey, hurry! I know this right. I can't read. It's supposed to go from moving around like that. I can still do it. Alright. What do you want? Well, if your original equation, your first linear equation has something that's second equation doesn't. Now, here's the thing. Here's the thing. Let's say you do So, obviously, in this case here, the first thing you have to solve for is which variable? X. So, X values. Guys, fine. X values, are they linear pair or are they vertical?
linear.
Linear pair, which means they have to add up to equal how much? 1. Good. So, combine your like terms, rewrite. You get, what, 19x?
plus 9, 180.
Okay.
9, oh, 171. 171 divided by 9.
Perfect. What do you, bless you, what do you do with that value of 9 then to solve for y?
Put it into one of the equations.
Does it matter which one you choose? Do you want to do linear pair or do you want to do vertical in this case? If we go vertical again, that means I'm going to take this 9 value here, and what's that angle become? 97. Very good. So that means that 18y plus 25 has to equal 97.
Okay, please don't change.
Okay.
Oh,
You know, using extra colors is always great to help show different pictures and how things get highlighted through. But you're right, sometimes you can miss a little bit if you write stuff up. So, real quick, now, what I'd like to do here, I'd like to skip ahead real quick. And I'd like you guys to look over to number 9. Okay? Number 9, the diagram looks a little bit different from stuff that we've done so far. But I'm pretty sure that most of you guys can try to figure this out. How many degrees does it take you to get around something? 360, which means 73, 222, and B have to add up to equal 60. Okay, very good. Skip over to number 18. 18, it shows that those two angles have to be what? 90-degree angles. Two angles that are adjacent that create a 90-degree angle. This case, we learned the term for it today. They're what? Complementary. Complementary. Right? Complementary angles are angles that create 90 degrees. Now, does it say that in this diagram that those two angles are equal to each other? Do you see tick marks anywhere? No. Which means, what do they have to add up to equal? 90. So that's the stuff that you're looking to do. Okay? You're looking, can you set up the equations via the diagrams, whether they're supplementary, 90, linear pair, things like that. What I'd like you guys to do tonight is I want you guys to go through, on this one, go 10 through 28, the evens, please.